So Lynn, we were just learning about soil and water, right? When during the daytime it was the soil heats up quicker than the water, and in the nighttime the soil cools quicker than the water. So we're wondering, how do those surfaces affect the air above those surfaces? So let's think for a moment. When a surface is very warm, what happens to the air above it? And when a surface is really cold, what happens to the air above it? So we're thinking the temperature of the air and also the way that the air moves, because we've talked a little bit about how warm air moves and how cool air moves. So let's think of maybe applying that to an investigation. So right here we have a cold surface. We've got some icy water, and in this cup we're going to actually put some very warm water in. You can see we have a hot pot over here heating some water. And so those are our two different surfaces. We've got a cold surface and a warm surface. So what's going to happen to the temperature of the air, and how is the temperature going to affect the way the air moves? So I'm going to write a hypothesis for that. So it says right here, if the air rests over a cold surface, such as the ground, then the air temperature will do what? I don't know. Could it rise, or could it stay the same, or could it go down? I'm not sure. That's your decision to decide. So I'm going to put a blank here, and you're going to fill that in. So the air temperature will do what? Going to go up, stay the same, or go down. And then, the air will move. How could it move? Well, maybe it could move up. Maybe it could go down. Maybe it won't move at all. So let's leave that blank, and you can fill that in. And that would be your hypothesis for what's going to happen above a cold surface. Now we have to write another one because we have two surfaces. So if the air rests above a warm surface, like the ground, then what's it going to do? Well, let's start by copying the same information we have. The air temperature will do what? I don't know. Maybe if it's warm, it might become warm too. It might go up. Maybe it might not change at all. Maybe it might get cooler. I don't know. You're going to fill in that blank. And the air will move. I don't know. You'll have to think about how you think that's going to move. Maybe it'll go up. Maybe it'll stay the same, or maybe it'll go down. Okay, so now we're going to try this. So let me get my warm surface ready. And I'm going to pour it in here. So this is pretty steamy. It's actually fogging up my glasses. Okay, that looks about equal. And we want to make sure that we're wearing our safety goggles because we are working with water and heat. Okay, so I want to start. So we have these convection tubes that we're going to be using. And before we put this over our surfaces, we want to make sure that we're taking the temperature. So the way that you take the temperature here, and I'm going to bring it up, hopefully we get a good view of it, is you look for the green, okay? Now here we don't have any green, but we do have a brown and a blue, all right? So the rule is if it's brown or blue, you look for the number in between. Okay, now if we look at the top here, we see that one side is Celsius, that's the largest numbers, and then one side is Fahrenheit. So we always use Celsius in science. So we're looking at, and here I see it's turning, is that green? We're looking at the brown and the blue, and we're going to just choose a number in between. So the number between 21 and 22 is what? All right, you got it, 21.5. So I'm going to record my starting temperatures for the warm is 21.5 degrees. And that's at the bottom, 21.5 degrees. And I don't have to worry about the top, right?
You're,
this one?
okay.
Yes? No? Yes, I do. Okay.
21.5 again.
Okay,
it's the
thank
same.
you.
Yep.
21.5?
Yep.
Thank you. So nice that you've done this already. Okay, and we're going to do the same thing, recording the temperatures for this. Okay, so can you figure out what that is? Can they see the brown and the blue? Okay.
Yep.
All right, again, we're looking at the brown and the blue here, and we're making sure that we're reading the Celsius, so it's 21 and 22. So we're going to go between, and that is 21.5. Okay, so 21.5, 21.5. Okay, so we've got our starting temperatures. So at this point, I'm ready to put the convection tubes over my hot and my cold surface. And maybe, Lynn, you can help me? Mrs. Powers, I should say, right? So you ready? Get my timer started. Okay, 1, 2, 3, go. And I'm going to start the time. Now we're going to leave this time going for about 5 minutes because that's about how long it takes us to do the temperature. All right, now while we're getting those temperatures to change, what I'm going to do is turn off the light, and what I'm going to do is introduce some smoke from a punk stick. Now, I want you to think for a moment, why would we introduce smoke? You thinking? Okay, so we use the smoke so that we can see the way that the air is moving, because we can't see air, but the smoke will help us to actually visualize that movement of the air. So I'm going to turn off the light, I'm going to get this punk stick started, and then we're going to introduce the smoke to those tubes. Okay, and how about if we start with the warm first? Okay, we want to make sure that we have our sleeves pulled back. And here we go. Put it in here. And you're just going to leave it in there for a little bit. Now, while that's in there, what I want to do is use my flashlight, because I want to see if I can tell where it's going. Up there, I see some evidence of the movement. So let me follow all the way up. And what do you see? What's happening to the smoke? Okay, we should be saying that the smoke is moving up. Now, if I look down through this hole, I don't see any evidence of the smoke going down, because if it was going down, it would be coming through that hole. So I'm going to put this out for a moment, and I'm going to record what I saw. And when you record the movement of the air, you can use arrows. Okay, so make sure that you're labeling the correct one, or hot and cold. And we did the hot first, so I'm going to show some arrows of the air moving up and out. Okay, and here's my punk stick with a little bit of smoke introducing. Okay, now let's see what happens with the cold. Maybe we'll see the same thing. My punk stick lit. Make sure your sleeves are back, hair's out of the way, and I'm going to carefully introduce it. And I'm going to wait and see what happens. So let me get my flashlight, and let's see. Wow, can you see what that smoke is doing? So let me follow it up. Okay, I do see some rising, but I also see that smoke going down. Okay, if I go to the top, I see a little bit coming out, but if I look close at the bottom, I'm seeing it's gathering around the bottom. Here, let me put that out. Do you mind if I pass that to Mrs. Powers just to put out? Okay. And here I can see more evidence of that smoke going down, and I can even see it within the tube. If I go to the top, I don't see much of it coming out. Okay, I'm going to go down to that bottom hole and see if I can see any coming out. Boy, look at, can you see it? Mrs. Powers, you come right over on this side. So you see it coming out that little hole on the bottom, just gently? Yeah, wow, what a great view. Okay, so can we make any conclusions about the way that the air is moving above the cold surface? Well, what do you think, Mrs. Powers?
Sinking.
I would say so also, because I don't see any coming out of the top. So let me record that observation. that I saw above the cold water, my cold surface, here's my punk stick going in, and that air moved down, right? And I might even have a little hole right here showing that the smoke went out. Okay, so let's check our time. It's almost 5 minutes. I think we probably have some good data. So I'm going to stop the time right now, and I'm going to turn my light on because what I want to do is record my final temperatures. So I already know that the air went up in the warm and down in the cold, but now I want to see what the temperature is of my air. And boy, does that look foggy. So I'm going to take my thing to clean off the side so I can take my reading, okay? So I'm going to go down very gently to make sure that I do not knock off that temperature gauge. I'm going to record my temperatures. Okay, so I don't know, can you see this well? So my temperature, I see some green there at the top. So I'm going to be recording my final temperatures. Okay, the green is at the 24. Boy, that is hard to say.
Oh, I was on the wrong tube, sorry.
That's okay.
There we go.
Okay, good. I can see it perfectly. So over, I think you're on this one. Yep. So can you see it right at the 24? So I'm going to say my final ending temperatures at the top, make sure we're recording it in the right spot, is 24 degrees. And at the bottom, boy, that's going to be tough to read. I'm going to just reach across and grab this one. Oh, students, right? Oh my gosh. Oh, sorry, I should have probably left that on. All right, there we go. Perfect. All right, let me get this one all the way down so we can record it. All right. See, we can't even edit this stuff out. Oh, no.
This is raw footage. That's the best part.
This is what I tell them not to do. Okay, we're going to just carefully push this through without hopefully messing up our data and get that out of there so we can read it. Okay, so let's take a quick reading while it's visible and I'm looking up. I don't know, can you see that maybe from this side? It's all the way up at 29 degrees. Okay, it's actually rising between 29 and 30. So our final temperatures at the bottom are 29.5 degrees. And let's see what happened with the colds. Okay, this is a little bit easier to read. So we're looking at our bottom temperatures at the colds. We see it's 22. Okay, so I'm going to record that. At the bottom, 22 degrees. And our top temperatures, doesn't look like it changed very much. So I've got 21 and 22, so it looks like it's still about 21 and a half. All right, so what could I conclude from this? Let's see. Well, I already saw my smoke in the cold. It went down. And what's happened here to my temperatures? Can you see? Well, I see at the top it stayed the same. But look what happened at the bottom. Looks like it went up a little bit. So above the cold surface, it went up. We'll have to think about that one. Maybe there's a reason why. Now, let's look at our warm surface. We saw that the air moved up. And then what happened to the temperature? Well, let's compare. At the top, we see that it went up a little bit. Wow, look at the difference at the bottom. So it was 21 and a half, and now we see that it's 29 and a half degrees at the end. So that's an increase of 8 degrees. So what I can conclude is that air above cold surfaces seem to move down, and the temperature stays about the same. And again, we'll have to talk about that tomorrow during class because maybe these are unusual circumstances or unusual data. And here, for the warm, we see that it went up and the temperature also goes up. So thank you for joining us. So please make sure that you turn your page over and start answering the reflection questions on the back. And then we will see you at the end of class.
Bye-bye.